p-value. Recall, we used the z-statistic to help us decide whether or not to discredit the null hypothesis. The closer the z-statistic is to 0, the less reason we have to doubt the null hypothesis. The farther the z-statistic is from 0, the more the null hypothesis is discredited. We saw this in the last video, and we looked at a picture like this towards the end that deals with flipping a coin 20 times. So you can go back to that video if you don't know what I'm talking about. Okay, so what is a p-value? Well, the definition of p-value is the p-value is a number that measures the probability that if the null hypothesis is true, a test statistic will have a value as extreme or more extreme than the value we observe. This is hard to understand, so we're going to dig deeper. Intuitively, p-values measure our level of surprise if we assume the null hypothesis is true, conduct an experiment, and observe a result. Small p-values, those that are closer to 0, means we're surprised. We get a result that surprises us. In other words, we get something far from our null hypothesis. Large p-values, closer to 1, means that we have a result that's not surprising. In other words, close to our null hypothesis. Why are we looking at values that are close to 1 and closer to 0? Well, probabilities are always between 0 and 1. So p-value is a probability, so it's something between 0 and 1. Now, let's take a look at an example we saw in the last video. So all possible outcomes for spinning a coin 20 times in terms of the test statistic and the number of heads are shown below. In particular, if we are interested in whether or not a coin we're spinning is fair or unfair, we might spin the coin 20 times and observe how many heads we got. Now, we would expect, as a null hypothesis, to get 50% heads, or about 10 out of 20 heads. Now, you can see this null hypothesis here, H0, says happens often, so we would expect, as if the coin were fair, we would get around 10, or maybe 9, 8, 7, 6, or something a little more than 10. But this general range right here you're looking for down here, it's like the most likely thing to happen if the coin is actually fair. Now, the red values that you see, those are ones that are considered more unusual if we assume the coin is fair and that the null hypothesis is true. So if we get something like 5, 4, 3, 2, 1, or 0, or like 15, 16, 17, 18, 19, 20, that's going to be less likely to happen if the coin is really fair and our null hypothesis is true. So in this picture that you guys are looking at, the second line shows the corresponding z statistic that goes with each number of heads you could get out of 20. So we saw in the last video that our z statistic is going to be like farther from 0. Like when it's farther from 0, we have a more surprising outcome. Now, the outcomes in red, they have a smaller p-value, so a small p-value goes with a more surprising outcome. And the outcomes in black have a larger p-value, those go with a less surprising outcome, so like outcome closer to the null hypothesis of about 10 out of 20. So to get a better sense of this, let's suppose you spin a coin 20 times and count the number of heads. The null hypothesis is that the coin is fair, or we get about 50% heads. The alternative hypothesis is that the coin is not fair. Now, which of these outcomes, 3 heads or 9 heads, has a smaller p-value and why? So to think about this question, you want to think about, well, if we get 3 heads out of 20 versus 9 heads out of 20, which of these is less likely to happen if the coin is fair? Well, if the null hypothesis is correct, then we should expect to get about 10 heads. So we should get 10, give or take some amount. Now, 9 heads is much closer to 10 than 3 heads, so 3 is a more surprising outcome. This goes with a smaller p-value. So more surprise, smaller p-value. Okay, let's look back at the definition of p-value. It says, assuming that the null hypothesis is true, the p-value is the probability that if the experiment were repeated, you would get a test statistic as extreme or more extreme than the one you actually got. Now, what does this whole as extreme or more extreme thing mean? I think it's a little bit confusing. Let's figure it out. So let's look back at this flipping a coin or spinning a coin 20 times example. Suppose we flip a coin 20 times and count the number of heads. The null hypothesis is that the coin is fair and we would expect to get 10 out of 20 heads, or 0.50. Probability of getting heads is 0.50. The alternative hypothesis is that the coin is not fair. Let's suppose we carry out a hypothesis test. We learn how to actually do this in 8.2, next section, and we end up getting 3 heads out of 20. So we do our experiment, we get 3 out of 20. We're told that the p-value for this experiment is 0.03. What does it mean to have a p-value of 0.03? So it means that if we believe that the null hypothesis is true, in other words, we believe there's a 1/2 chance of getting a heads each time you spin the coin, then the probability of spinning 3 heads or less, or 17 or more, is 3%. So when I say we get a test statistic as extreme or more extreme than the one you got, in this scenario, it would be 3 heads or less, or 17 or more. That would be like as extreme or more extreme. Why does it mean, why would those numbers give you something as extreme or more extreme? Well, let's look at all the things that could happen if you spin the coin 20 times. We could get 0 heads, 1 head, 2 heads, 3 heads, 4, 5, 6, 7, 8, all the way up to 20. Now, if we got 7 heads out of 20, that would not be as extreme of a result as 3 heads out of 20. Now, 3 out of 20, we can think like if the coin were fair, that's like super unlikely, right? 3 out of 20 is not that many heads. We would expect to get more like 10. So 7, that's not as extreme as getting 3. 6 is not as extreme as getting 3. Neither is 14. But getting 3, that's as extreme as getting 3. Getting 17, that's as extreme as getting 3 because it's just as far from 10 as 3 is. Getting 2 is even more extreme than getting 3. Way unlikely, it seems, if the coin were fair. Getting 1 or 0, also very extreme, more extreme than 3. Same thing with 18, 19, and 20. So I've highlighted in red the outcomes that are as extreme or more extreme than getting 3 heads out of 20. So a p-value of 0.03, it is the probability of getting an outcome as extreme or more extreme than the one we see if the coin were fair. So if the coin were fair, we expect to get 10 out of 20. We conduct this experiment with a p-value of 0.03. The probability of getting something as extreme or more extreme, in other words, the probability of rolling a 0, 1, 2, or 3, or a 17, 18, 19, or 20, if our p-value is 0.03, is 3% chance.